contribution of ships to air pollution increases. At the same time, environmental regulations become increasingly stringent. The SCIPPER project, funded by the European Union's Horizon 2020 project under the 2018-2020 transport theme, aims at monitoring with special techniques the air pollution from ships.
We will be using a number of methods and techniques, including onboard sensors, sensors flying with drones, remote optical sensing and sniffer type of instruments. We will be even exploring whether satellites can be used to monitor emissions from vessels.
The objective of work package 1 is to investigate onboard monitoring of pollutants emissions in a very broad sense, so including the gaseous emissions, SOx and NOx, and also several kinds of particle emissions like black carbon and particle number. Like I said, in a broad sense, so it includes basically the data transmission and also reporting formats and metrics in a sensible relation to the legislative requirements.
My name is Johan Mellqvist. I'm from Chalmers University and I'm a work package leader for the work package 2. And this work package is about developing measurement techniques to measure ships remotely. It's also to harmonize some of these techniques to report, so they report in the same way.
When we have new technology and new rules, we are hoping to get benefits for air quality and public health in the shipping. And these benefits are of course calculated through models, air quality models. But ship exhaust is an aerosol. It has particles and gas phase components. And the aerosol that reaches the people on the shore is not anymore the same that leaves the ship. It ages. And VP3 tries to give new scientific information for the modeling of this plume aging.
And a key problem in the science of modeling this aging of the plume is that the different components in the emission are not very well characterized, and it's actually technically very hard to characterize the full emission. And in VP3 we tried to approach this problem from both the modeling side and the experimental side.
So in work package 4 we will do the city scale and the regional scale air quality modeling. So it means we will look at certain regions where the ships under investigation in the other work packages will travel, and we will model the transport of the pollutants and the chemical transformation in the atmosphere.
So in work package 5 we're going to synthesize the knowledge we get in the SCIPPER project and do recommendations for how to policymakers, how to improve the regulations, for example, and to improve the monitoring. So we will start out by looking at loopholes in the regulations and how the present regulations are enforced in different parts of the world. We will take the results from the work packages, do measurements on board and remote measurements, and suggest cost-efficient ways to do this monitoring. We'll also take the results from the air quality studies, the modeling, and look in scenarios how we think the impact of shipping will influence air quality in the future assuming different levels of compliance with regulations and different types of regulations and so on.
The techniques will be deployed in on-field campaigns that will be conducted in various seas in Europe. In the Mediterranean, the port of Marseille, in the Baltic Sea, the ports of Gothenburg and Hamburg, and also the English Channel.
In the framework of the project SCIPPER, two campaigns will be carried out in the Marseille harbor, which is the second largest harbor in the Mediterranean Sea for cruise and container ship. The first campaign will take place soon in September 2019 and will deploy drones and remote sensing to measure emission from ship and ferries before changes in sulfur content in the fuel that will occur in 2020. The second campaign will occur 1 year after this shift to lower sulfur content, and we'll implement other measurements in addition to those that I already mentioned. We will have also the deployment and the test of different sensors in the onboard the ships. And we will also measure the impact of boat emission and ship emissions, measuring with state-of-the-art instrumentation inside the harbor and in different parts of the city. All these data together, they will highly implement air quality model to better understand the impact and contribution of both emissions into the city and the regional scale.
So the second campaign in SCIPPER will be on a Stena Line roadpax ferry going from Gothenburg to Kiel. We will do a lot of onboard measurements, which is the special thing about this campaign. We will place a lot of sensors in the exhaust gas channel of the ship and compare these measurements to high-end measurements that we do simultaneously. So the sensors will be tested for the first time for marine use, and they will be further developed during the project.
Measurement campaign 3 will focus on the intercomparison of different compliance monitoring methods. So all different kinds of remote compliance monitoring will bring together to one measurement site to measure the same ships under the same conditions with different methods, with different analysis to get the same results, and also to develop a harmonized reporting tool to the authorities.
My name is Tim Smythe. I'm from the Plymouth Marine Laboratory in the United Kingdom, and we're going to be running campaign 5 of SCIPPER. What we plan to do in campaign 5 is use two of our assets at the Plymouth Marine Laboratory. So we've got a vessel called the Plymouth Quest, and we've also got a shore-based asset called the Penley Point Atmospheric Observatory. And what we're going to use within the project is we're going to use the Plymouth Quest to sail out into the entrance and the exit of the sulfur emission control area. We're going to be using various techniques upon the Plymouth Quest in order to measure the emissions of different ships. We're also going to be able to use the Plymouth Quest to take ground truth measurements for the satellites. So the satellite measurements generally are confounded where there's different sources of pollution. In the Western English Channel, it's a fairly pristine atmosphere. So we're going to be able to use different techniques to be able to ground truth the satellites there.
We're all very excited with this project, and we invite you to follow our activities.